The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to Advanced Applications with Parle Microphones. If everybody can hear me, maybe give me a thumbs up and just let me know in the chat that you can hear me okay, and we will get started here. My name is Jason Kleiman. I'm an applications engineer. I've been with Biamp just a little over 5 years. I joined in February of 2015, and I've been in the audio world for quite a few years. So I live in southern Indiana. I believe some of you, I saw a few names on there that were familiar, so I'm sure I've talked to some of you on the phone before. And we have 4 of us now that are located in either the Eastern and Central time zone to make sure we have some availability, sorry about that, availability during the morning so you guys don't have to wait until everybody's awake on the West Coast. So I'm sure I've spoken with many of you, and I'm sure I will speak with some of you if I already haven't at some point in the future. So I take care of a lot of technical support, and over the last couple of years, I've dealt with the Parle microphones quite a bit. So this webinar originally started last year, and we were going to go into quite a bit of the stuff that we normally do when we do design files with Parle microphones. But in the time that we originally scheduled this, we had a new release and we introduced a new feature. So much of this webinar is going to actually go over some of these new features, specifically focusing around the Parle processing block. So we've created something for you to make some stuff that was difficult and challenging before, just because it was a lot of work and a lot of thought process that had to go into it. And we've tried to make something very, very simple for you to use. So we're going to talk about the Parle processing block. We're also going to talk a little bit about tracking limits. So with the Parle microphones, we can now restrict tracking to certain areas. And I want to go into the special use case of divisible rooms because that one tends to be a little bit confusing and requires some additional work. And we're going to talk about the new feature of giving individual beam outs from each Parle microphone. So there are a few applications for that, and I will show you how to do that. And we're also taking a look at this from a little bit of an advanced perspective, and assuming that you have some basic knowledge of what the Parle microphones are, what they do, how they work, the Tessera software and how that works as well, and are a little bit familiar with the Parle microphone design tools that we have available on Cornerstone at support.biamp.com. We have a calculator that allows you to put in the room size, the room acoustics, settings, and it'll actually tell you how many microphones you're going to need to cover that particular room. We have the same for the tabletop version and also the speakers as well. We have a speaker calculator as well. So let's get going. I may not be able to stop for questions right now if I don't have the ability to get to your questions during the presentation. I'll make sure I get a follow-up out afterwards, because I'm going to try to cram all of this in 1 hour, and I've got quite a bit of material to cover. So let's get into the Parle processing block. So we've had the TCM1 microphone on the market for, I guess it's been almost 2 years, maybe a little over 2 years now. And it's evolved in how that gets deployed in rooms and what we need to do to make a room sound good has evolved over the last couple of years. And when we introduced the newer version of the Parle microphone, which is the TCMX and TTMX versions, much of those same concepts still applied. But we found that there were differences between the microphones, and we need to do a little bit of general front-end tuning, and we usually do the same stuff in just about every room. So why don't we create a block that allows you to just drop one block in that takes care of most of that processing for you? So that's where the Parle processing block came in. And the whole goal of this block is to give you a simple one-click solution to get simple basic rooms, actually it's more complicated rooms, but basically to get a Parle microphone up and running with minimal effort. So this little pink block, or actually it's not pink, I guess it's more of a purplish blue block, is the Parle processing block, and this is a 4-channel version. And if you double click on that block, we give you a very, very simple user interface. You have some room acoustic settings, and you can pick between poor, fair, good, great, perfect. And we'll talk a little bit more about exactly what those mean here in just a minute. But in a lot of applications, you can just drop that in and pick the room acoustic settings that are applicable to your room, and it'll take care of the EQ, it'll take care of compression that we have in there, any gain that we need for that microphone, and it'll do most of the work for you, and that may actually get you exactly where you need to be in many situations. And sorry, just 1 second here. What do those mean? So in a perfect world, a conference room would have a noise floor of about 35 to 40 dB weighted, which gives us an NC or noise criteria rating of between 25 and 30. Sometimes that's a little challenging to get. We consider that a perfect room. Also with an RT60, which is your reflections in the room, you'll hear RT60 referred to often as the reverb time of the room or reverb in the room. Well, in a really small room, it doesn't really have a true reverberant field, and we're mostly concerned about these reflections that are bouncing off walls, hard table surfaces, glass windows in these big fishbowl-like conference rooms. Designers love it, acousticians hate it, because they're very live rooms. You have a lot of very strong reflections, and we want that to be less than half a second. And we want a signal to noise ratio of greater than 25 dB. Now, the signal to noise ratio is the difference between your noise floor and your talker, the level of the person talking in the room. And that includes a difference between your reflections, so your reflection levels and the talker level in the room. And what's important to remember is that matters at the microphone more so than down at the talker position. So at head height seated, yeah, that's typically where you're going to take your noise floor measurement, but you really need to take a measurement to get an idea of what the noise floor is, where the microphone is located, because it may be closer to a noise source in your room, close to an HVAC duct. If it's in the ceiling, so there may be some noise sources coming in through the drop ceiling, vibrations in the structure, and all of that adds up. So you need to know what that noise floor is at the microphone. So if you've looked at our calculator, which I hope all of you have at some point in time on support.biamp.com, you've probably looked at the calculator and noticed there are some acoustic settings, and we've defined a range of noise floor levels and RT60 times to go with what we consider poor, fair, good, great, and perfect acoustic settings. So again, a perfect room, less than 35 dBA. A really, really, really bad room, what we say poor here, is going to be greater than 45 dBA, or a very long RT60 time in there as well. And the maximum mic to talker distance goes down as the noise floor gets worse. So you're improving that signal to noise ratio by getting closer to the microphone. And as you can see with the TCMX, that's 6 feet from talker to microphone in poor acoustic conditions. So it's something you just need to be aware of. And what we do with the Parle processing block is we drop that in with a default, and we're assuming good. So somebody could go in, create a file, and know enough to be dangerous, and they could drop this Parle processing block in there. And we've got some processing in there to account for a majority of the cases that we've seen over the last few years. So we set that to good. And that's your starting spot. So another advantage to the Parle processing block is we can now include the AAC processing inside the block. So when you drop the block in, it gives you a little checkbox, and if you check the include AAC block, it's going to actually take the AEC processing block that you're familiar with from, hopefully you're familiar with by doing other systems with, or other Tessera systems with AEC processing. That block is actually going to be inside the Parle processing block, and it's going to be pre-configured with the settings that we've determined are best for beam tracking microphones. But you don't have to do it that way. And there are applications where you may not be able to do it that way. And you can uncheck that box and then use the AEC processing blocks outside. In that case, you need to make sure that you go in and configure that block correctly and make sure that it's set up for the beam tracking microphones. And there's actually a check box that you can check when you drop in an AEC input. But you have the AEC input block and the reference separately. If you just drop the Parle processing block in with that box checked, it will give you just the AEC reference block. So again, we're making it simpler by doing this. So we've added the settings that are available in the AEC processing to the interface form for the Parle processing block. So we can set our room acoustic settings, then you can go in and set up the AEC, NLP level, active noise reduction. You can get to the meters from there as well. And on the right, that's what it looks like if we don't include AEC. You'll have to go in and manually set that stuff up in the AEC processing block. So we've given you poor, fair, good, great, perfect. What if that doesn't quite do it? You're going to go into a room, you're going to get everything set up, you're going to do a test call, and you're going to listen to it. You're acting as the far end, and you're going to go cycle through those different settings and say, well, I measured the noise floor and it said I should be in good. I click it over to fair. Fair has some noticeable improvement, but there's just some difference between good and fair that I just feel like I could do better. So we've given you the option to pick custom. And when you select custom, you get a little plus sign on the block itself, which allows you to open that block up and get access to all of the internal processing. So if you're familiar with Tessera and the processing library that we've used in the past, it's very similar to that, except you can't edit this, you can't add blocks, delete blocks, or change any of the wiring inside this block. It's all fixed, but you can access all of the DSP settings to adjust things to meet your needs. And your base point is always going to be the selection that you made right before you did custom. So if you start with good and then go to custom, everything in this block will be set as good, and then you can go in and you can make the adjustments. If you set it to poor, it's going to be poor, then you can go to custom and it'll start out at poor, and maybe you need to go in and adjust the compressor after that, or maybe the EQ is just a little too aggressive for your needs. You can go in and make those adjustments. So let's go through relatively quickly here exactly what the processing path is and why it's here. We have a block in here called digital mic gain. With the Parle blocks or Parle microphones, we're coming in over AVB, and those are all digital. So it's a digital signal path from the microphone into the DSP. So now we've lost our mic pre's, and our mic pre's were always our first stop when setting gain structure with analog microphones. So we don't have those anymore. So we need a place to make up some of that gain, and we've introduced the digital mic gain block in here. And you can't edit that, it's actually fixed. So when you drop in a Parle processing block, you pick your microphone type, whether you have a TCM1, a TCMX, or a TTMX, and that gain will be fixed based on the microphone type. And it is 12 dB of gain for a TCM1 and 18 dB for a TTMX and TCMX. Next in line, we have an advanced compressor block. And again, we're assuming a little bit of familiarity with Tessera software, so you're probably familiar with a regular compressor block. So we've set this block up to work in advanced mode, and advanced mode gives you the ability to create an expansion curve and get this block to run as an expander. Normally, a compressor takes signal levels over a certain threshold and turns it down. An expander is the opposite of that. As it drops below a fixed threshold, it actually turns it down more. So what this does is turn your noise floor down. It's not filtering out noise. It's not making the noise go away. We have active noise reduction on the AC input block that does some of that. Basically what it's doing is it's making the noise less annoying to the person on the far end. And it works very fast. So as soon as somebody starts talking, however much we've turned it down basically turns back up to normal and it goes away. So in between words, in between syllables, then any background noise will be turned down based on the settings in here. We find that it makes it a little bit less annoying to the person on the far end if you put a little bit of expansion in there and turn that noise down a little bit more when you have high noise environments. And again, these settings change as you go from perfect to poor. And in perfect, we're not doing any expansion because we're assuming that that noise floor is, in that NC 25 to 30 range, and we don't need to turn the noise floor down because it's not there and it shouldn't be there. So this is just a little tool in the bag of tricks that we've been using for a while to improve performance in really noisy rooms. So next in line, we have some EQ. And these are 5-band Uber filters built into the block. And we have the preset EQs that we've determined work well with the microphone in different conditions. So we tested this in quite a few rooms, and we've gone back and looked at quite a few of the cases where we've done room tunings in progressively noisier and noisier rooms. And something we find that's common, even back before microphone arrays, back when we were just doing conferencing systems with regular ceiling microphones, a microphone picks up the room noise, of course. It can't discriminate. Your ears can discriminate between noise and direct sound better than a microphone can. A microphone's going to pick it all up. A microphone typically gets less directional as you go down in frequency. So most microphones, a cardioid microphone, a super and hypercardioid microphone, some of them are almost omnidirectional down in the, below 200 hertz, definitely below 100 hertz. So they pick up a lot more noise, and then the higher frequencies are nice and directional and pick up only in the direction that it's pointed. Well, the same really holds true for a microphone array as well. They get more omnidirectional as you get lower in frequency, and most of the noise in a room is low frequency noise. So what we find is that we need to roll off the low end. And I like to tell people frequently that when you're tuning a room, you really need to roll the low end off more than you probably are comfortable with doing, because visually it looks like you're taking out a lot of stuff here. But in reality, you're not taking out anything important. You're not taking out anything in the speech band. But as we get noisier and noisier rooms and we have more and more problematic noise sources in the room, we filter out more low end to get that out of the range so it's not masking our speech intelligibility. So that's what we have with the EQ curves here. And then we go into a gating auto mixer, and the gating auto mixer is pre-configured for beam tracking microphones. So that feature is enabled. We're using the direct outputs, and it's also set up for last mic hold. So it's really annoying to the far end. At least I find it annoying. Some people may be okay with it, but I always find it annoying when everything turns off. So if somebody in the room suddenly goes quiet and everything gates off, you hear nothing and you think that the call has been disconnected. And then suddenly you're saying, hey, are you there? So the last mic hold eliminates that. It keeps at least one microphone always open, so you're hearing at least the room itself, so it's not shutting off the audio stream, and then some far-in sources will inject comfort noise, which sounds different, and then that just leads to people thinking there's something wrong with the system when there isn't. So last mic hold is a good thing. For larger systems, you may want to limit the number of open microphones, which you can do that. When you go into custom mode, you can turn that on and it'll limit it to 1, 2, or 3 microphones. Then after the auto mixer, we run through the AGC. We're not going to go into any detail of the AGC here, but we find that AGC works best when it's post-gate after the auto mixer. So we've disabled AGC in the AEC processing block, and we've put it after the microphone. And if you get your gain structure set correctly, this is a great place to go to know if your gain structure is set where it should be. If everything else in front of this is where it should be, then your gain meter on here should be within, +2, -2 of 0 here once when somebody's talking on that channel. So this is a good place to go to see if you got your gain structure set right. If you see that it's maxed out on the gain, or it's got 15, 20 dB of attenuation, then you've got a gain structure problem, and you should correct it there. If you don't, it's going to create audible problems downstream. So then in here, we mix all of that back together. Then we run into a standard compressor, which is there to get rid of really quick, loud transients. So if you have a door slam, if you have somebody that suddenly talks really loud after someone that's talking quietly, then the AGC is going to be a little bit slow to kind of catch up with that. So this compressor is there to catch those transients and turn them down to make it a little bit more comfortable for the person on the far end. And then we have a mute block in here, and that mute block has a logic input, so you can drive that external to the block with a logic state or something else tied to a control system. And we also provide the logic out so you can monitor the status of that block. So moving right along, let's talk about the tracking limits that we've added. So a TCMX and TTMX microphone, I like to describe them to people as 4 small, tiny microphones that are constantly moving inside this little puck-shaped object, and they're constantly turning to try to look at the person that's talking. So when it hears somebody talking, it points that microphone at someone as long as it's within that 90-degree arc. So if you think of this little diagram, we have a red, a yellow, a green, and a blue microphone inside here, and as somebody talks, if they're within the coverage area of that yellow microphone, then we point that microphone in that direction. So the TCM1 is 3 beams, and each beam has a 120-degree coverage area. So the TTMX and TCMX are 4, and each one is 90 degrees. So with the TCMX and TTMX, we added the ability to turn off a certain area of that tracking. And again, this does not apply to the TCM1. So you have to have one of the TCM or TTMX microphones. But in a case like this, we have a small huddle room, and we want everybody seated at the, this table's up against close to the wall, and nobody's going to set up against the wall. So what we want to do is turn off this area that's facing the display in this case. Maybe there's a credenza under there that's putting off a lot of fan noise that's getting picked up. Maybe we've got some strong reflections bouncing off the surface of the display that's causing that red beam to gate on. All of that's possible, and we want to turn that off. There's just no need for that. So what we've done is we've taken each 90-degree arc and broken that up into 45-degree increments, which we can now disable. So we can tell the microphone, hey, if you hear something in this 45-degree area, don't gate on and track to it. So that allows us to change the way our coverage works a little bit. and we can turn off these areas that will never have any usable or any sound that's going to be necessarily picked up. So let's look at a little bit of a different application here. Let's take a rectangular shaped boardroom with some ceiling microphones, excuse me. So these are the TCMX arrays, but we have a door back here, and we've installed this, and we find that this door it doesn't really block out the sound very well. Maybe it's got a gap under it, and people are really loud in the hallway, and it's just really annoying, and people on the far end during conferences are hearing that, and it's bothering them. Well, we can turn that microphone so we can get that 45-degree segment facing that door, and then we can disable it. So we can stop it from tracking to that area. So that's another application for that. Now the next one here, let's take a look at a little training room. So in this case, we have 12 table microphones and 2 ceiling microarrays. What we want to happen is this. We want the table microphones to only pick up the people that are seated at the table with the microphone. We don't want that to get picked up by the microphone that's behind the person. And then we want our our TCMXs at the front of the room to only track to that front area to pick up the person that might be walking around presenting and talking at a whiteboard or something. So let's take a look at this example, and I actually want to build this file to show you what's going on and just talk you through the process of how this works. And so you can find out that it's pretty quick. We can create a pretty complex system in a really short period of time. So I'm going to start by dropping in my Parle blocks, and I go up to the input-output block, which is the little pink arrows, and then I go down to microphones, and I pick Parle microphones. And again, Parle microphones now encompasses the TCMX, TCM1, TTMX, and the versions with the amplifiers. So those are all rolled into the Parle microphone family. So I need to pick my microphone type, and in this case, I'm picking a TTMX. And I had 2 microphones per table, and that works out to the maximum number of microphones we can have on a network box. So the TCMX and TTMX have a little network box, and the microphones plug into the network box, and that network box then supports up to 2 microphones. So we define those by being 2 inputs. So you have a main microphone and an expander on one box. That gives you a 2-input block. And then we have some options here for picking logic. If this is set to none, then the internal mute on the microphone and the LED ring on the microphone will always be in sync. So if I mute the microphone, then the LED ring will go from green to red, and the LED ring will just reflect how the mute state is. If I set this to logic inputs control LEDs, now I have the ability to turn that LED on or off and turn it between red and green based on external logic in the file. So I can sync up multiple microphones. I can use a control system that's controlling a mute downstream, and I can have the LEDs be in sync with that. And I can also just turn it off. There are people who want the LED to go completely off when the room is not in use. So then when you go into your control system and you do a power-up preset, then it's going to enable the LEDs. Then we have the option here to make the decision whether we want both of these microphones to mute in sync. So in this case, if I leave this checked, I have 2 microphone arrays on this particular block. If I mute one, it automatically mutes the other. If I don't want that to happen, if I want individual control, then I can flip back and forth and just use logic on 1 or number 2. I can also enable the logic outputs, and these are enabled by default. This gives me a logic output node that monitors the status of that mute. And if I pick the amplified version, the TCMXA that has a built-in amplifier, I now have the option to decide whether I want to include the amplifier block, and I can set up the amplifier block. I'll show you an example about that a little bit later, and I'll cover this beam block a little bit later as well. But for now, whoops, that is not what I wanted to do. Back to the TTMX. There we go. So now I have a TTMX block, 2 channels, and I need 6 of these for 12 total channels. So I can just do Control D in the software, and that'll duplicate this block that I have currently selected. You can also right-click and go to duplicate as well. I can duplicate an entire selection. So boom, here I have all 12 of my microphones, the tabletop versions. I need 2 ceiling microphones. I'm going to go back to my I/O blocks. I'm going to go to microphones and pick Parle microphones. And now I want a TCMX, and it's going to be 2 channels. So I'll drop that in here. Now for this room, we don't just have microphones, we also have a far end source, and we're going to say we have a program source as well. So I'm going to drop in a standard input block that's 2 inputs. And then I'm also going to drop in an EXUBT, which is our AVB USB interface with Bluetooth. I'm going to disable Bluetooth because it just adds more blocks. And I don't need that for the demonstration purposes. Move this output over the way over here. So now I have 12 TTMX microphones, 2 TCMX microphones, 2 additional line inputs, and my far end source, which is going to be my EXUBT. So I'm also going to drop in a, a level control as a control block in here. I'm going to make that 2 channels. I'm also going to drop in a single channel level control for my EXUBT. I'm going to drop in some Uber filters. Go in, drop in a 5-band Uber filter for some EQ. I'm going to Control D and duplicate that. So these are my program inputs to my system. And then I have a far end source coming in. And now what do I do with my Parle block? So in the past, you would go in and you would add EQ, probably add some level controls, maybe some limiters, compressors on there. Well, we're not going to do that. We're going to go up to the control block section. We're going to add a Parle processing block. I'm going to drop that in here. I'm going to leave include AEC checked. I'm going to pick my microphone types, and this is going to be the TTMX. And I'm going to go up here and set the size to 12 inputs. Now the Parle processing block has a maximum of 12 inputs. So you can have 12 microphone arrays tied to one Parle processing block. So that conveniently lines up with the maximum number of inputs available on a Tessera Forte. So let's wire that up. And then I'm going to drop in another Parle processing block. And this time I'm going to leave it, this is set for a TCMX. I cannot mix and match Parle processing blocks with different types of microphones. So we have the presets available for the room acoustic settings, and those are tied to the type of microphone. So in this case, I have the AEC reference that's dropped in with that. I'm going to move those over the way here, get them out of the way, connect this. And I'm going to go ahead and add a meter block in here. I'm going to go up to meters, pick an audio meter. I'm going to go ahead and make this 14 channels. So I'm going to go to custom, and I'm going to pick 14 because I want all of my microphones to show up on 1 meter block. And then I'm going to go down here and create another audio meter block that is 3 channels. And I'm going to drop that here. Actually, I want to drop it on the output of my level controls. Whoops. Like so. So that takes care of my inputs. Now, I'm going to need an output. I have one output over here for my EXUBT that's going to go to my far end. So I need to get audio to the speakers in the room. So now I'm going to go up and I'm going to add an amplifier. So I'm going to go to amplifiers and add a PoE amp, and I'm going to use a 450 BP. This is our 4-channel PoE plus powered amplifier. And I'm going to drop that in here. So now I have basically 4 outputs here that I need to drive. I'm assuming in this case, all of my speakers are the same speaker type in one flat ceiling. So I'm going to connect all of these to the same actual program source driving it. So I'm going to add some speaker processing in here. Now, in our processing library, we have a section here for DeSono speakers. I'm going to use the CIC6 block. So we have quite a few built-in processing blocks for the CIC6s. We have it for the community speakers. Don't know if we have it for any of the apart line yet, but this processing block gives us, oops, I can't get it open here for some reason. There we go. It gives us a high-pass filter that's already built in, a PEQ that is already set for a correction curve for the CIC6 speaker, and then a limiter in here as well, a peak limiter to keep us from blowing things up. And all of that's going to be the same signal, so I'm just going to hold down the Shift key and connect it to all 4 channels. So I actually need a total of 3 outputs for this system, and 1, 2, 3, 4, 5 inputs. So how am I going to route this? I'm going to do a matrix mixer. So I go up to my mixer blocks. I pick a matrix mixer, and I set it up to be 5 inputs and 3 outputs. So we're not going to get into the exact details of why I only need 1 AEC reference in this particular webinar. We have a whole other plethora of sources on Cornerstone and some past webinars to talk about AEC referencing and how all of that works. But for this purpose, we only need 1 AEC reference mix, and we're going to use the same matrix mixer output for that. So now I can connect my inputs. Let's pick all of these. Now I'm going to go in and set my routing in my matrix mixer. So in this case, I have input 1 are my tabletop microphones. And where do those need to go? Well, they need to go basically to the far end, which is output number 2. So channel 1 is going to go to output 2. Channel 2, also microphones in the room that need to go to the far end. None of these are being reinforced in the room. So we're going to send that to the far end. And then channels 3 and 4 program, those need to go to the amplifier and to the reference. And then our far end source, which is our EXUBT, also needs to go to the speakers and to the reference. And that basically sets our routing up. So the next big thing to do to get this going would be to go back and think about how we set up this room. We need to go in and turn these areas off for these tabletop microphones and the ceiling microphones. We just need to pick which areas we need to turn off. Let's flip back over there, show you this, and it is quite easy to do. If you double click on the Parle block itself, the Parle input block, you'll see we have this red, blue, green, and yellow color indicators around the side. I don't have this running live because I don't have that many microphones to actually send it to a file in my office, but for those of you familiar with the Parle microphones, this azimuth tracker will actually show you a little dot here. That'll be the color matching this outer ring, and that's going to show you when that beam is gated on and what direction it's pointing. So these little sections of color around this allow us to turn off that area just by clicking on it. So I just click on that red, and I want to turn that section off. And in this case, I'm going to say I only want these microphones to cover this 180-degree section down here at the bottom, which is the side of the table where someone is actually seated. Now, this little dot or little triangle right down here at the bottom represents the logo on the microphone. So that's how you know what the orientation of the microphone is. You just take a look at that logo, say, hey, that's the dot. Okay, looking at it from the top, in that case, we're going to turn off this area on the back side away from the logo. So that may not be the easiest. It may be a ceiling microphone, and you may not be able to see the logo because, you know, some of us, we've been staring at computers for way too long, and our eyesight isn't as good as it used to be. We have some additional utilities available in the microphones. Down here, the beam tracking setup utilities option is only available when you're online live with a microphone. What this allows you to do is pick segments mode. The LED ring on the microphone will now turn off to match what's turned off up here on the setup. So you'll see that LED ring turn off. In this case, it would turn off the backside, which is facing away from me. So this helps you orient the microphone correctly to make sure you're turning off the correct area. So I'm going to do that for, I'm not actually going to do that for all of these. I just want to show you how to do it on 2 of them. And then I'll show you the TCMX version, which is basically identical. Just click on that color and it will toggle off. If I accidentally turn the wrong one off, I can turn it back on. And in this case, the TCMX, I'm turning off this other section because that's how I'm imagining I have these oriented in this imaginary room that we're creating. Another option here in the beam tracking setup utilities, we have demo beams. We like to call this Night Rider mode. This actually will turn the LED ring on the microphone off, and then the part of the ring will illuminate, showing you which direction the beam is pointing. And again, you can have 4 beams, so you could have 4 LED areas on that ring actually active to show you which direction the microphone beam is actually pointing to at that particular moment in time. Another important setup here is the ceiling height. We're assuming these are 10-foot ceilings. In our imaginary room, again, it could be 9 foot, it could be 8 foot. You would need to go in and set that ceiling height as well. The beam tracking setup utilities, that's, again, a setup feature, which is in the name. This is only going to be active for 1 hour. So after 1 hour, this will default back to none, and the LED operation will go back to reflecting the mute state or the logic input to basically show you the mute state. We don't really want that getting stuck in segments or demo beams mode because it gets a little bit distracting. You see the little flashy lights on the microphone, and then suddenly everybody wants to stare at the microphone when the CEO is talking, and that's never a good thing. So we set that up to go back to normal operation after 1 hour. So we've set up our tracking limits. We've got our parlay processing blocks in here. This basically is pretty much a complete file, and it's not very complicated. It does not look complex on the surface. Our next step would be to set up our room acoustic settings based on what we've hoped would be the measured noise floor in the room. So we're going to go in, and let's say in this particular case, we're going to pick fair because this is not a very good room. It's got a lot of noise in it. And we would need to do some tuning online to get the NLP level set where we really want it, check the noise reduction, but that's beyond the scope of what we're going into here, the tuning specifics. But I do want to go into custom mode now. So we're going to split both of these into custom. Let's just say that fair didn't quite get us there. Maybe my expansion was a little bit too aggressive at that point. So I'm going to open this up, and boom, look at all that stuff. So this file, while complete, you may want to add some additional EQ, maybe some more level control, maybe there are some additional inputs and outputs here. If you have locally reinforced microphones in the room, you may be required to do a little bit of AEC referencing for those. So you may need to use a per channel reference, which we have another webinar on that as well. All that may change, but for the most part, this file looks incredibly simple because it's all included in here. So here we have our digital mic gain, our AEC processing, and again, our AEC processing block is configured by double-clicking on the parlay processing block. And this section here for NLP level, noise reduction, that's what we would normally set in that AEC processing block. But here we have a lot of stuff. We have our compressor, and let's just say for this room, if this was just a little bit too aggressive, but the EQ was right, maybe I want to go in here and back this off a little bit. So that's something I could do when I'm commissioning the room. We have our Uber filters, a gating auto mixer, our AGC. All of this is pre-configured based on those settings that I just picked, and all of this would have taken you a lot of time to copy and paste and copy DSP settings, paste DSP settings, get your baseline settings, all of that stuff. You'd probably spend, I don't know, 15 minutes, 2 hours. I don't know how fast you would be working in Tessera, but it's going to vary from person to person, but it'd take you quite a bit of time to get all of this stuff set up and configured correctly. So we've done that with one block now. So it makes life quite a bit easier for you. So that covers the Parle processing block. I have a couple of questions here. See, I want to look at those. Can the mute button on the TTMX be programmed to control a post-AEC mute block? No, the mute button on the TTMX right now is tied to the mute inside the microphone. Let's see. Can you now use Parle mics for local voice reinforcement? Ian, shame on you for asking that question. Sorry. That's a common question we get a lot. You can use a microphone for whatever you want to use a microphone for. Our stance historically has been that ceiling microphones should not be used for local reinforcement microphones. Can you do it? Yes. People have done it successfully, and a lot of people have tried to do it and had very poor results. The poor results are not because the microphone is doing something wrong. The poor results are because the basic PAG-NAG formulas are just on the wrong end. Some rooms, it doesn't matter what microphone you put in there in the ceiling, you're going to get poor voice lift performance because your talker to microphone distance and your speaker to listener distances just are really bad. Now, the tabletop microphone is much closer, and in a case where you have some sort of zone speakers, you could probably get some decent voice lift out of the tabletop microphones, especially in a situation like this where you're breaking down these beams and you're not turning them on in those areas. So you could probably get some decent gain from your back row up to your front speakers, assuming that the system is designed correctly. And that is the key here. The system must be designed correctly with the acoustics in the room, the speaker locations, your microphone to talker distances, and your speaker to listener distances. All of that has to add up correctly to get good voice lift. So hopefully that answers that question. I'm going to keep moving along here because I do have quite a bit of stuff, and I'd like to try to keep this under an hour. And again, if I can't get to all the questions today, I'll make sure I follow up with them afterwards. So let's run to the next situation, which is a divisible room. This is not uncommon in the corporate environment. I mean, this has been around in hotels and convention centers for ages, where we have rooms that have air walls and they're divisible. You can use it in maybe 1 division, 2 divisions, maybe 10 divisions for a big ballroom. So we see a lot more of these showing up in offices now, where we want a large room that can actually be split down the middle. In fact, one of our lunchrooms at Biamp, we recently renovated it, but it used to be divisible into 2 sections, and we would use that quite a bit in both combined and divided mode. So this is pretty common. And in this case, we have a room that has the size warrants 2 TCMX microphones in each room division. So let me show you how you would do that, because there are definitely some differences when it comes to putting this together. So again, I'm going to run through some of these basics fairly quick. I'm going to drop in a 2-channel Parle microphone, TCMX, and in this case, I actually want to pick a TCMXA because this has an amplifier with it. So this is the amplified version. I'm going to drop this over here. I'm going to drop in another one. Like this. I'm going to drop in an EX UBT for my far end source. So I have room A, I have room B. I'm actually just going to Control D and duplicate that. And if you try to duplicate something that requires another block to go with it, it gives you a little warning about that. So here I have, whoops, this should be an A. So now I have 2 TCMXAs and 2 EX UBTs for this divisible room. So how am I going to wire this up, and what do I need to do? So the simplest explanation on how to do this is if you go in and you drop in a 2-channel parlay processing block, and in this case, we're going to include the AEC again. So let's put this up here, and I'm going to just duplicate that one. Tells me I need the AEC reference to go with it, which is perfectly fine. It's over here. Drop this one down. So now in this case, I have an EXUBT and 2 microphones. I have that mixed down to 1 mix output. So I actually need 2 inputs per room. So room A is here at the top, room B at the bottom. So I need a 2-input matrix mixer. Sorry, I can't talk. A 4-input matrix mixer. And I need 3 outputs per room. So it's going to be a 4x6 matrix mixer. And if you didn't know, you can go to custom. If you don't want to use symmetrical values, you just go to custom and pick your inputs and outputs. So let's see. In this case, I'm not going to add any EQ. I'm just going to wire up these outputs, no additional level controls to keep you from getting bored to death and just watching me draw this stuff on the screen. And in the real world, we would make this look much prettier, but today, for this, we can't quite do that. Although I will line these guys up because that's driving me crazy. Okay, so I have my outputs. I have 3 outputs per room, and then I have 4 inputs. My parlay mics from room 1 and my parlay mics for room 2. I'm going to go ahead and wire these up. Now, as I'm wiring these up, I want to tell you that some situations may be perfectly happy right here. So in this case, we have a divisible room, and what we're going to do is go in and create a preset in the matrix mixer, and that preset is going to have a combined mode and a divided mode. And for those of you who have done this in the past, you'll know that there are some things we usually like to do when we combine rooms, which is what we're going to talk about. So let's take this. I'm going to open up my preset manager over here. I'm going to go into my matrix mixer and set up my routes for my divided room. So microphone number 1 is going to go to the EXUBT for room 1 and only room 1. Input number 2, which is my EXUBT, goes to the speakers and the reference, and then we do something very similar for room 2. So that sets up our matrix route for the divided scenario. If I hold down the control key, left click on the matrix mixer, drag it over to the preset down here at the bottom, I now created a preset, and that's going to be my divided preset. So now I want to go in and create a combined preset. In this case, I'm just going to go in and duplicate this preset, and I have a copy up here to duplicate that one. And I'm going to call this one combined. I'm going to make sure that one is recalled. You can know it's recalled by the 4 little squares over here on the left. And I'm going to go into this matrix mixer and set this up for being in combined mode. So microphone number 1 is going now to both EXUBTs. The EXUBT for room 1 is now going to go to the speakers in both rooms, and the microphone for room 2 is going to go to both EXUBTs, and then basically both EXUBTs go to the references and the speakers. And then once that's done, I go over to this little icon up here in the preset manager, the down arrow, which is to save that preset, and now I can toggle between my combined and divided presets, and it will combine and divide those rooms. So in some cases, this may be perfectly fine, but one thing that we run into problems with in rooms where we're using auto mixers is now we're not taking full advantage of the auto mixer. So we have an auto mixer in here that's 2 inputs, and we have an auto mixer here that's 2 inputs. Well, if we combine our room, wouldn't it be nice if that auto mixer combined, or both of those auto mixers combined together and became one 4-channel auto mixer? Well, we've been doing that for a very long time with the auto mixer combiner block. Up here under mixers, you can go to auto mixer combiner, drop this in, pick the mixer type, whether it's gating or gain sharing, And in this case, we only have 2 auto mixers. I'm going to change this to 2. And now I have an auto mixer combiner block. The thing is that for this to work correctly, I'll set this to custom so I can open it up. The auto mixer combiner needs to see this mix output on the auto mixer. And that doesn't actually go anywhere in the Parle processing block. So if you want to use the auto mixer combiner in a divisible room, you can't use the Parle processing block. So kind of thinking in the back of your head, well, so that kind of takes the fun out of this thing. Well, we've added some stuff to make that easy for you as well. So we have the processing library, which hopefully you're all familiar with. If you go to Cornerstone, support.biamp.com, and do a search for Parle Custom Processing Catalog, we have a processing catalog that's designed for using the auto mixer combiner. So I'm not going to go through the details on how you download this and install this, but basically this will guide you through. This article will talk you through how to download it, install it, and how to use it. But once it is downloaded and installed on your computer, you should have a Parle Custom Processing Catalog in your library. And over here we have TCM1, TCMX, TTMX in 1 to 8 channel counts. So if we want to use this auto mixer combiner, we need to use something from this library. So I'm going to go in and I'm going to delete this. And then I'm going to go in and drop in a 2-channel TCMX, sorry, these are TCMX, a 2-channel TCMX custom block. It looks very similar to the Parle processing block, and I'm not going to wire that up yet, but I can duplicate that, Control D, wire that up to my matrix mixer, and now this basically takes place of the Parle processing block. So the big difference in here, one, we don't have the digital gain block available for custom block, but we do have the same gain modifications in here to match the microphone type, and we have the presets based on good. So that custom room acoustic setting preset, whatever good was for the TCMX, TCM1, or TTMX, that's what this block is going to have. So the disadvantage of this was you will have to go in and adjust it as necessary to get it to work based on your acoustic conditions. But this is the same signal flow with the same base parameters. Big difference here is this mix output on the auto mixer is now going to an output on this block. So we have this output for a mix out, and this is going to go to our auto mixer combiner, which will allow us to talk, basically allow the auto mixer combiner to communicate with the auto mixer in that block. Now, if you notice, our AEC references disappeared because these blocks do not have the AEC processing in them. So if you drop in a Parle processing block and don't use AEC processing internally, or you use one of the custom blocks, you have to do it the old-fashioned way, which is go up to the input block and pull in an AEC processing block. And in this case, I'm going to uncheck the include AEC input block because I don't want the analog inputs, and that gives me my 2 channels of AEC processing right here. Now remember earlier where I said we pre-configure that for you in the Parle processing block? Well, we do, and this one is not pre-configured because if I go back to block properties, I forgot to check the pre-configure for beam tracking mics box. So you have to check that box, and that will disable the AGC and maybe make a couple of other modifications in that block. And it says BT for beam tracking here to tell you that that's what we've done. So that's now configured to work for a divide combined room. I'm going to duplicate that for room B. Let's wire that up. Oh, that did not work right. There we go. So there we go. This is how we would do it in the past. And now if you needed to edit the AEC channel, you would need to double click that block, make your settings here, and then go into the custom block and make any adjustments here that you would need. Now, with this, I already have a combine divide preset. I'm going to recall my divided preset, and in this case, my auto mixer combiner is just going to not function. So I have nothing selected, and I'm going to control click and drag that into my divided preset, and then I'm going to recall my combined preset. Now I want to set up my auto mixer combiner to work in combined mode. So to do this, I just assign them to a group. So based on number of inputs and outputs, you have multiple groups, and when you assign them to the same group, now they talk, and the auto mixers function as one auto mixer. So where before I had two independent two-channel auto mixers, now when I go into combined mode and have this selected in the same group, this section down here overrides the auto mixer settings. So if I want to set up last mic hold, boom, but it's going to be last mic hold 1 of 4, not 1 of 2. If I want to set up an open mic limit, which I often do, I can go in here and say I only want one microphone gated on, and it's going to only gate on one of those 4, whereas before, if you don't use the auto mixer combiner and you set that to 1, you could still have 2 microphones gated on, because each auto mixer has 2 channels, and 2 auto mixer channels means that, 2 separate auto mixers means that it could gate on 1 from each auto mixer. So then to save this in the preset, I hold on the control button, control key, and just click and drag that into my preset. And now that gives me a simple 2-way divisible room. Now, if you have 3-way divisible rooms, you need more presets. You're going to need 1 to do separate. You're going to need 1 to do A plus B, B plus C, A plus B plus C. So the more rooms you have, the more presets you need. So let's jump back here, and just a quick recap. When you're doing room combining, you want to use presets in your matrix mixer and room combiner to combine and divide rooms typically. The auto mixer combiner block, you definitely want to use that if you have more than 2 microphones in each room division. I've definitely also seen rooms that didn't require the auto mixer combiner. They may have only had 1 microphone array in each room, and it was a well-behaved room. And again, the combiner may not gain you any noticeable improvements if you're just doing it with 2 microphones. But if you want to use that, you have to use the custom block. The Parle processing block does not allow the auto mixer combining. And the custom blocks give you that auto mixer mix out, which you'll have to use for that. So moving on to our last feature that we're going to go through here are the individual beam outs. And what this allows us to do, which I will just jump straight over, software demos after this, sorry. So each TCMX and TTMX have 4 beams, which we mentioned earlier, and those beams are mixed down to a single audio channel that comes out into the DSP. This means that you only need to use 1 AEC channel per microphone. But again, we talked about having 4 little microphones in one array here. So that's it works great, but there are cases where you may want to use those individual beams. So internally, we have this mixed down to a gain sharing auto mixer built in the microphone. And it's not the same gain sharing auto mixer, but that you would use if you were doing a regular DSP file in Tessera. It's a little different, but for all intents and purposes, it's a gain sharing auto mixer to do that mixing. Well, with 3.14.1, we added the ability to individually use each one of the audio channels from each beam. So you'll have 4 inputs. Now, the disadvantage to this is, of course, it requires more AEC channels. So if you want to use all 4 beams, you need 4 AEC channels as opposed to 1. Also, it's not compatible with the Parle processing block, so you'll also need to use the custom processing library blocks and maybe make some adjustments on your own as well. So I do apologize for running a little bit over time here, but I'll wrap this up quickly and then try to get to any questions. And again, if I don't get to your questions while we're on here, I'll make sure I email you an answer. So let's go in and drop in another microphone. I'm going to drop in a TCMX, and in this case, I'm actually going to select this Use Parle Beam Blocks option. And if you notice, that drops in a completely separate block that is attached to this top block. And as with all things Tessera, these blocks have a little number in a box down here, and in this case, number 1. That tells you that this block goes with this block, so you don't get them confused. So this block is the same. No change here. Let me change this to 2 channels. Now I have 8. So now I have the 4 beams with microphone number 1 and the 4 beams from microphone number 2 now available post everything, or sorry, pre everything. This is just the raw beam output. There's no auto mixing going on. There's no gain adjustment going on as the auto mixers kick in. This is just raw audio that beam is picking up. So that comes in here and you can use it. So in this case, I would need to bring in back to my processing library, and I need 8 channels, and this is a TCMX. So I'm going to bring in my 8-channel TCMX block. And if I want to go through AEC processing, I also need to drop in my 8-channel AEC input. I'm not going to include the analog input here. And now I can connect these up. And again, this gives you a good starting place because this block will probably get you 60–70% there with its default settings of good, and then you would have to make some adjustments from there. So why would you want to use this? Well, you may have a really bad room and you may need to limit the number of beams that are active at any given time. Well, you can't do that with the mix, the regular default block, because that mix has the potential of gating on all 4 beams at the same time. So this is now going to bring each gain or each beam individually into a gating auto mixer. So only 1 could be gated on, maybe only 2 would be gated on. It just is dependent on the settings that you have configured in the auto mixer. So there are cases where you may want to do this. It'll also give you a really simple way to track beam activity. Down here, we have the gate outputs of the auto mixer. So anytime the auto mixer is gated on, it's going to reflect that in this logic output down here. So we can track which individual channel is gated on. So that gives you a very easy way to do camera tracking. As long as it's focused in that region where that particular beam in that 90-degree arc, then when that one gates on, it'll give you that logic which you could use to trigger a camera preset. So that's very useful. You can still do that with creative control system programming. You can subscribe to the actual Parle block, and it'll tell you, which one is pointing which direction and what the level is and what the angle is and all that kind of stuff. But it gets a little complicated to do that programming. A very simple way is just to do this. You can use the auto mixer settings in here. If you want to use the beam outs just to track cameras, you could put signal present meters on here and just look at the signal present meter to find out which one is active and above the threshold at that particular point in time. Now, you can double click on this block, open it up, and it gives you your segments for each mic and which color is associated with that, which correlates with the color on this block. And a cool little function here too, if you want to make them look like Pac-Man, which I love to do, you can go in here, and when you turn off the beams in the main block, it actually will reflect that, so you have that indication that those are not active. And let's see, just make that look a little different. So you know that those areas aren't active for that particular beam. So we have individual mutes available now for each beam, which maybe you have a need for that. So that'd be another reason to use the beam mounts block. You may need an application that mutes specific areas at specific times based on maybe room configuration or selection from a control system. And we can individually adjust the level. You may have one particular beam that's pointing in one direction. You have people there, but you want to turn that down a little bit. So you could actually do that. Yeah, somebody just brought that up, caught that. This is height above floor. I think I may have mentioned ceiling height earlier on this microphone. I said that because the TCMX is mounted flush up to the ceiling. So yeah, that's height above floor. And the same is true for the TCM1. It gives you the height above floor, so you may have to do a little math to calculate that. But so I'm sorry if I misstated that earlier. The other thing here with the logic, we have the logic out coming out of the TCMX, and by default, that's tied to the logic in for each individual beam. This means that if you mute the input on this one, it's going to automatically mute all the beams at the same time. If you want to control those individually, you can just delete, and then you can add maybe some logic states and tie them to these individual beam inputs to individually mute them. So that covers the new individual beam outputs block. And that basically is everything that I had to go. So I'm going to jump to a few questions. Thank you all for attending. And I hope this was useful for you. Please send me some feedback if there were any problems as well. There should be a recording for this available through the original link. Eventually, it takes a while to actually process that, get it downloaded. And if I don't get to any of the questions that came through here, I will email you about those later. So let's see. The largest height that you can use, the question is how high can you go? The largest height that you can actually go to with this is actually 18 feet. That is the largest amount you could put in here. But I would not put a TCM1X on an 18-foot ceiling. If you go back to some of these, let's see, let me jump back to this in this presentation. If you look here, in a perfect world, your maximum mic to talker distance between the person talking and the TCMX is 16.3 feet. And that's if your noise floor is less than 35 dBA. So if you have any questions on exactly how to do that, please go to support.biamp.com and look at the ceiling microphone parlay calculator, and it will help you with that. Because while we're saying that mic to talker distance, of course, is going to be less than that 18 foot because we're standing or sitting, so there's a difference in height there to your actual mouth and the microphone, and the ceiling would still be a little higher. But with any ceiling microphone, you've really got to keep an eye on your signal to noise ratio and the distance. Was another question about if you use the parlay processing block, what happens if you want the include AEC, you can't use the analog inputs. That is something we are actively looking at. So the question is, let me show you really quick here. Let me go back to this demo file. Oops, that's not the right one. This one. So I've included the AEC processing, and if you actually go into this block, if I compile it, you'll see that it compiles with it's telling me I need a Forte AVB CI, an AVB VT4, and then it wants me to use an EXIO for these two analog inputs and outputs here. But if you're familiar with Tessera Forte, you know that we're using the AEC processing in Forte, but we're not using the analog inputs. So how do we use those? Well, right now, the option to do that is to not include the AEC processing in the parlay block. So we would just have to uncheck the include AEC processing block, and then I would go up to the input outputs, and I would just add my Tessera Forte blocks like you've probably always done in the past. And it's going to bring in your analog input block and your AEC processing block. And in this case, we can go in, we can add that in line. I can go in here, I can, let's see, connect my reference here. And then I have my analog outputs available as well. And that is something we're looking into actively to see if we can make that be a little bit more friendly for you. So right now, if you are using the analog inputs, you will need to do the AEC processing externally. So we are about 12 minutes over time. I'm going to go ahead and shut the webinar down. If I didn't get to answer your questions, I will take a look at those and respond to you via email. And again, thank you all very much for attending today. Goodbye.